Friends, welcome to our channel. Let's look at today's daily challenge problem. Number of substrings containing all 3 characters. In this video, again, we're going to use two-pointer sliding window method. So two-pointer sliding window. So here for this problem, as you can see from my previous video for problem C, you can regard this as a follow-up for problem 1839, right? So in the previous video, we mentioned that when you write two-pointer sliding window methods, you have 2 choices: either use a for loop or use a while loop. So here I'm going to use a for loop because this is very natural. So here, given a string S consisting only of characters A, B, C, so we want to find the number of substrings containing at least one occurrence of all these characters A, B, C, right? So if you look at the example 3, so this is very special because the length is 3, so just only 1. And if you look at example 2, so in order to include A, B, C, you should either start from index 0 or 1 or 2, but onwards to the end. That's the 3. So here it's very interesting to analyze this one. So here you can, if you look at index 2, so you can only start from index 0, so this gives you 1. And if you look at index 3, so you can start from 0 or 1, it gives 2. But if you look at the index corresponding to this second B, so you can start from 0, 1, 2, right, gives you 3 possibilities. If you look at the last C, you can start from index 0, index 1, index 2, and index 3. So this gives you 4 possibilities. So 1 plus 2 plus 3 plus 4, that is the 10, right? So with the walkthrough for example 1, and it's easy to do idea like this. So for each right index, right pointer, let's say R, we find how many valid substrings ending there, right? So basically, to find how many starting points, I will see the left pointer, because once you flex the R, so it's the further to the left, the better, right? So that's why we just do this kind of counting. For example, here, if you look at this C, right? So you can, if you just look at this ABC, it actually forms the valid one. Then any left index, the index less than 3, that will be good. 3, 2, 1, 0, right? So that's what we are going to do. So with that said, let's look at the coding. Actually, the coding is very short, right? So we get length of this S. And then we initialize a result variable. Let's see. This is whose final state is to be returned. This is the our overall thing. And then we can start a left pointer, right? And then we're going to use a window to monitor this. So we can use a dictionary or can use a counter, right? So what we are going to do is that for the right pointer in range n, so we find the largest L such that we are still in the from, so let me we find the L such that, so from L, find L, largest L, such that, so from L to R, form a valid substring, right? So this is what we are going to do. Then you can count the index from 0 to L. Those are the possibilities of valid strings ending at the index R or right pointer R. So first we are going to include the current character, so that's SR, into the current window, right? And then we are going to do a check, because here we have only 3 unique letters A, B, C. So we can do this like here. Well, window, so call A is greater than 0, and window, say B is greater than 0, and window C is greater than 0. If all the three conditions connected by the two ends holds, then we can push L to the right? So basically window SL, so it comes decrement by 1, and then we increment L by 1, right? So this way, once we exit this while loop, actually we can restrict, say L is less than or equal to R. But if L equals R, for sure, this conditions cannot be simultaneously held, because in order for this to be held, the length of the window should be at least 3, right? Therefore, we don't need that condition. So after we exit this loop, so there must be at least one of those does not hold. In other words, so the current state of L, state of L is such that, so from L minus 1, then onwards the current R, they form a valid substring. Therefore, so the starting indices can be, say L can be 0, let me use L naught. L naught can be 0, 1, 2, up to and include L minus 1. So overall, this L possibilities, right? Because 0 from up to L minus 1 will be L possibilities. Therefore, our result should be incremented by L. Actually, to write it more clearly, it should be L minus 1 minus 0 plus 1. So this is the end point. This is the starting point. This is the one, right? Then we are going to return the result. Let me first run it to test it. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases, I guess. Yeah, so here actually I want to make one comment. So when you use two-pointer sliding window method, so you need to pay attention to monotonicity, right? So here actually, if you have an R and then R1, the corresponding L1, right? And then you have an R2. R2 is, let's say, greater than R1, and the R2 corresponding to L2. So then the relation will be the following: L2 is greater than or equal to L1, right? Because we include one more character to the when we increase R, then we might be possible to shift L to the right, but still we have valid substring. That's why we can do this. In other words, we don't need to start over L. So this monotonicity actually makes the coding structure sound, or if you want to say, this can be regarded as a proof of correctness. So with that said, I guess that's basically about it. Actually, we noticed that for these several days, the problems are focusing on two-pointer sliding window method. So actually, we have a playlist in our channel containing problems that can be solved by two-pointer sliding window method. So you are welcome to check out those videos, especially you look at the to digest the comments in those videos. I guess those comments actually should give you some general guidance on how to approach such problems. With that said, I guess that's basically about it for the current daily challenge problem. Thank you for watching.